So in question 6, okay, we're dealing with trigonometric functions. It's our favorite part of the whole paper. I think this is probably like the easiest marks you can ever get in a paper. Okay, so let's look at this, right? In the diagram, the graph of f of x equals to tan of x plus p degrees, apparently, is drawn for the interval. X is the element of a closed interval with from negative 135 degrees until 180 degrees. Okay. And then over here, they say with asymptotes at x equals to negative 45 and x equal to 135 degrees. Okay. Now, what they are telling us is that we have asymptotes over here. We have an asymptote over here at x equals to negative 45 degrees. And we have an asymptote here at x is equal to 135 degrees. Okay. And then what they're saying over here, the tan over here is drawn in the interval from negative 135 degrees included until 180 degrees included as well. Okay, so that's essentially the domain. So that is the domain of f. Okay, now, what else are we going to be doing? I think that's about it. So now let's answer the questions. Okay, so 6.1 says the following: write down the value of p. Okay, so what is the value of p, right? This is the shift, right? The horizontal shift, or we can call it the phase shift. So what is happening over here, right, is that if we're going to answer this question, so let me just go a little bit down over here. There we go, cool. So let's say that this is 6.1 over here, right? And then our p-value, with what we can see on this graph over here, here's our tan, right? We already know what our tan looks like by now, but our normal tan would actually look something like this. It would be like this and like, whoa, not like that. So it'll go from here until here, where our asymptotes would be 90 degrees on both negative and positive, right? But as you can see, this graph has just shifted 45 degrees to the right, which means our p-value would actually be, because it's shifted to the right, we're going to look at the negative sign, and this is negative 45 degrees. Because if we put it back into the bracket, we're going to have to change the sign. So therefore, this is our p-value. Or let me write it in black over here. It's p is equal to negative 45 degrees. Okay. All right, so the next one over here is 6.2, right? So 6.2 says the following: draw the graph of g of x is equal to sine of 2x. So that's a double angle of sine x. For the interval, x is the element. Okay, so it's the same domain as what they gave us over here. On the grid, given. So we don't have a grid, so we're going to do like a nice rough graph of what it would look like, right? So essentially, I'm going to draw it on here, right? I'm going to draw it all on this graph here that we have. So show all intercepts with axes, as well as the minimum and maximum points on the graph. Okay, that's perfect. So what I'm going to be doing here, right, is, so it's a double angle of sine, but let's not focus on the double angle right now. What I want you to focus is on the following over here, right? Let's look at our sine of x graph, right? If we have, let's say, for example, f of x is equal to sine of x, or let's just say g of x for now. G of x is equal to sine of x. We're just going to transform the graph. And we have a graph that looks something like this, right? So it would look like this, and it would start at 0, and then it would move all the way until here. It reaches 360 degrees, and that's a full cycle, right? So that's its period there. And then it does the same thing here until negative 360 degrees, right? Now, it has an amplitude of positive 1, you can see over here. So therefore, the maximum is going to be positive 1, and the minimum is going to be negative 1, right? Now, that is our normal sine of x graph. Now, what if we say sine of 2x? Now, if we say sine of 2x, right, let's consider the following. If I'm going to just take this away quickly. Okay, so sine of 2x, right? So g of x equals 2 sine of 2x. Cool. Now, you can see this is our b value, right? Our b value. However, we are going to look at the graph, we're going to see that we have, in order to find our new period, right, we are going to take 360 and divide it by b, if you can remember that, right? And we know our b value is equal to 2, right? So therefore, it's going to be 360 divided by 2. Sorry, it's degrees, by the way. 360 degrees divided by 2, which is therefore going to be equal to 180 degrees. And that's our new period, right? So our new period is 180 degrees for this one. But as you can see over here, it is going to be in this domain over here. Sorry about that. So it's going to end at 180 degrees, so somewhere here, right? And it's going to, so there is no horizontal shift or vertical shift, so therefore we are going to start at 0, right? So let me do it in a different color actually. I'm doing it in purple. So let's say we're starting at 0, right? And what we are going to be doing is we are going to, where we would normally have 180 degrees. So remember, normally our sine graph would look something, it will start like here, right? So then it would start here and then it would move all the way like that, right? Okay. And then instead, now we are actually going to, because we halved the period, it's actually going to look like this. And then the x-intercept is going to be 90 degrees. Can you see? And then it's going to go move towards 180 degrees like that. I'm just going to assume that, oh, never mind, this is -1. Perfect. And then this will be +1 over here, right? Cool. And then obviously we have to do the same with the other one. So we're going to have to draw it like this over here, such that it intercepts over here by -90. And then it's going to stop somewhere around here. Cool. It's going to stop somewhere around here, such that this is in line with the -1. Okay, so that's our new graph of G. Remember, you have to label your graph. This is G. I want to do it nice over here. There we go. That's fine. Okay, so we sketched it, right? But remember, it says show all intercepts with axes. So intercepts is going to be over here. This is going to be our x-intercept, which is 90 degrees and 0. And as well as the minimum and maximum points on the graph. And we know this one is going to be, this maximum over here is going to be 45 degrees and 1, +1. And this is going to be 0 and 0. Remember, it's the origin. This point here, which is the minimum, is going to be -45 and -1. This point over here is going to be -135 degrees and +1. So it's going to be, sorry about that, +1. And then this minimum over here, remember we're still missing that one over there. And also this, there's a lot of things. So I'm just going to put all of the stuff in. It's -90 degrees and 0. And then this is therefore going to be 135 degrees and -1. So there's all of our points. And once again, we already showed the intercepts. We showed the maximum and minimums. So there we go. That's already question 6.2 done. Let's move on to 6.3, which is the period of G. Okay. We already established that the period of G is going to be 180 degrees because we used this, right? So I don't know why they have to ask the period question afterwards if essentially what we are going to be doing is still, we are going to, sorry, I'm not feeling so well. We have 360 degrees, remember, which was the original period from a sine graph, right? And we have to divide it by the b value to get ourselves a new period, which is 180 degrees. So therefore, the answer for 6.3 over here is going to be equal to, so 6.3 is going to be equal to, the period, you must say the period in full, is equal to, sorry, of G is going to be equal to 180 degrees. Okay, let's move to the next question. So what we have next is going to be 6.4. So 6.4 says the graph of G is shifted 45 degrees to the left to form the graph of H, right? So G, they're talking about the double angle sine graph, right? Sine of 2x. And over here, they're saying that the graph of G shifted 45 degrees to the left, okay, to form H. Okay, determine the equation of H in its simplest form. So essentially what we're going to be doing over here is we're going to take the sine over here, right? So remember, so 6.4, we're going to say that the sine of 2x, right? That was original, sorry, no, it's g of x, was equal to sine of 2x, right? And now if we're going to determine our new equation h, so we're going to write here h of x is going to be equal to, and now remember it said it shifted 45 degrees to the left, so which means it's going to be plus 45 degrees to the left, meaning plus an angle, or to the right, meaning minus an angle. So it's going to be sine of 2x plus 45 degrees. Now I want you to pick up my mistake, right? I'm pretty sure if most of you have probably picked up a mistake that I've made, right? You can see that I completely disregarded the following, right? So we would have, let's say for example, f of x equals to a multiplied by sine of, let's say it's going to be bx minus p, in our case over here, right? And then plus q. Okay, so what we actually needed to consider is this over here, right? So what we should have done here was actually to take the 2 out like this. So let's do it like that, right? Such that it'll look like this. We should have substituted the 45 degrees within the x, right? Because remember, the x is shifting, and if we put the 45 degrees outside, then we're saying that the period, there's something happening with the period as well, which I'm pretty sure when we go to tertiary education, you will understand why that is an incorrect formation. So that's why you need to stay true to this over here. So let me actually just quickly get rid of that so it kind of looks correct over here. You can see there, that is what we have. So let's simplify further now that we found out that mistake here. H of x is equal to, then we have sine of, now we're going to multiply the 2 into it, right? Now you can see how this b value is actually going to affect the entire x, right? Because remember, it's x, and we are affecting the x, and that is why we are going to have to put the bracket around the x and include this this positive 45 inside. So it's going to be of 2x plus 45 multiplied by 2 is 90 degrees. Okay, and now what we can see is we have a 90 degree over here, right? So then we need to determine, is this going to be a positive or is it going to be minus after we're going to reduce this angle over here, right? So what we're going to be doing, we can clearly see that this is the angle 90 degrees plus theta, right? Which is going to be quadrant 2. And we know that sine is actually positive in quadrant 2, right? So therefore, the final sign that we're going to be using is positive in that case, right? So it's going to be positive, cosine now, because it's the 90 degree, reducing the angle, positive cosine of 2x. And that is our new equation of h of x. Okay, so now 6.5 says the following, right? So it says use the graph to determine the values of x in the interval of, x is the element of negative 135 degrees until 0 degrees. Now they're changing it, right? And that's a closed interval, right? Because it's square brackets. For which, and we have 6.5.1, which says f of x is less than or equal to negative 1. And then the other one is, okay, we'll focus on that after answering this question. So using the closed interval over here, right, I'm going to be showing you what we are going to ignore. So you can see it's until 0. So we're not going to focus on anything past the y-axis. So that's our red line. And then from negative 135, it's going to be from here until there. So which means we're only focusing on the stuff over here between the red lines. Okay. So they say for which values of x is f of x, which is the tan. So we know it's going to be the tan. We know that f of x is equal to, tan of x minus 45 degrees, right? And let's look at that interval, right? Where is it going to be less than -1? Less than or equal to -1. So remember, we are talking about the ranges, right? So the ranges. Why? Because we are talking about the y values. We know that f of x is actually our output value, right? So therefore, we're talking about the -1, which is right over here. Sorry, now that's completely gone. Okay, now we need to consider this, right? From -1, so less than or equal to -1, right? So they're saying that it is equal to -1, but less than, meaning it still goes down. So we're talking specifically about this over here. From this point at -1 and all the way down there. And we can clearly see that if we go from left to right, it's going to start from 45 degrees, right? So we have from -45 degrees. And it goes all the way until, because it's including -1, it's going to touch the 0 degrees. And those are our x values. So therefore, we have 6.5.1, which is going to be x being between -45 degrees and less than or equal to 0 degrees. And as you can see, the reason why, once again, I am going to, okay, sorry, now this is very, there we go. Now, as you can see, right, this tan graph never touches -45 degrees, because remember, that is the asymptote. It will never touch the asymptote. That is why we don't include this inequality. And the reason why we're including this is because, once again, it says less than or equal to -1, and at -1, the value is 0. So that's why we include the 0 degrees. All right, now next one. Okay, so I've been sitting at this one for a little bit of time. I wouldn't say a lot of time, hopefully. Hopefully I haven't been here for so long. But I've been sitting here for a while, and I realized over here for this question, so we're doing 6.5.2, sorry, that we have, okay, so let's write it down, right? So we have sine x multiplied by cosine of x plus 2 is less than 2, right? So obviously our approach is to make sure that the right-hand side here is equal to 0, right? Or is 0. So that's what we're going to do. We're going to take the 2 over. It's going to be 2 minus 2. So we're going to minus 2 on both sides. These are going to cancel. And then we're going to get these also going to cancel. And then therefore we are left with sine of x multiplied by cosine of x is less than 0. Now, I can't believe it, but I feel so smart. And the thing is, if you do this in the examination, then I'm not going to be proud of you. So if you can remember, the one graph that we had was g of x, right? Remember that g of x is equal to sine double angle x, right? So double angle sine of x, right? Sine of 2x. And what we see over here, I almost got it like immediately, but I was thinking, yeah, they're giving this question, that's crazy. If we were to recognize this, we are just missing a 2, and then that would give us actually a double angle of sine, right? So if we were to multiply both sides by 2, we would actually get the following over here. So then we would get 2 multiplied by sine of x multiplied by cosine of x less than 0. Thankfully, the life of university mathematics has really opened my mind to these things. And I wasn't actually expecting this type of question to be in an examination, especially it's a prelim, so it kind of makes sense. So here now we have our double angle, and now we can write this as sine of 2x is less than 0, and we have exactly what we have here. And now we are trying to determine for which values of x is g of x less than 0. Can you see? So where is g of x less than 0? Now remember, we have our closed interval here, which is from negative 135 until 0, right? 0 degrees. So where g of x is actually going to be less than 0, we can clearly see we are talking about the 0 over here, so it has to be negative, right? And must not include the intercepts. So it's going to be less than 0 between negative 90 degrees and 0 degrees. Can you see that? But we're not going to include it. because once again, they didn't include anything over here. So we're going to do that. We're going to say it's x. So therefore, sorry, this was also 6.5.2. So therefore, we're going to have negative 90 degrees is less than x, which is where x is also now less than 0 degrees. And that is our final answer.